Hello, this is for ISOL 631 at the University of the Cumberlands. This is for textbook security policies and implementation issues. This is chapter 15, IT policy, compliance, and compliance technologies. Maintaining compliance with laws and regulations is a complex IT environment and is difficult. The vast array of regulations a company must comply with is constantly increasing and changing. Consider too that it's not unusual for different regulation agencies to issue conflicting rules. This means sometimes you have to manage to the intent of the regulations as much as to the letter. At the center of most regulations, intent is data protection. Stop the flow of data, and just as quickly you will disrupt the delivery of products and services. If the loss of the data lasts long enough, the viability of the organization itself comes into question. Laws that require notifying consumers of data breaches are a good example of conflicting regulatory rules. Each state has its own set of laws and regulations that indicate who is covered by the law and what event triggers a notification. For example, the state of Alaska requires notification of the data breach for any organization with 10 or more employees that maintains unencrypted personal information about Alaska residents. However, there's a provision in the law waiving the notification requirement if there's a reasonable determination that no harm will come to the consumer. In contrast, the state of Illinois requires notification of data breaches for any entity that collects data on Illinois residents. Notification is triggered upon discovery of the breach. No exemption is cited. The exact language of the laws is not important for this discussion. The point is that the two breach notification laws that look at the same event and the same data require potentially two different actions. In case of Alaska, no notification may be needed. In case of Illinois, the size of the company makes no difference. The initial reaction might be, why the concern? Two states and two laws. But the internet has made business borderless. Just consider the confusion of reporting if an Alaska company that ships products from a warehouse in Illinois had a data breach. Which law applies? Not to mention the question whether the order that contained the personal information received and stored in a third state. A company now must navigate a maze of jurisdictions and conflicting laws. That's how vital data is for many organizations today. Now consider the regulatory view of how to process, manage, and store data properly. To address this challenge across a changing landscape of regulations requires a solid set of information security policies and the right tools. A lot of time and energy goes into ensuring that security policies cover what is important to an organization. These policies help an organization comply with laws, standards, and industry best practices. Implemented properly, they reduce outages and increase the organization's capability to achieve its mission. The alternative could be fines, lawsuits, and business disruptions. So the learning objective of this chapter is to describe the different issues related to defining, tracking, monitoring, reporting, automating, and organizing compliance systems and emerging technologies. Topics that will be covered include what a business definition for information system security is, how to track, monitor, and report IT security baseline definitions and policy compliance, what automating IT security policy and compliance involves, what some compliance technologies and solutions are, and best practices for IT security policy compliance and monitoring. So the goals of this chapter are, when it's completed, you will be able to explain a baseline definition for information system security, define the vulnerability window and information security gap, describe the purpose of a gold master copy, describe the importance of tracking, monitoring, and reporting IT security baseline definitions and policy compliance, compare and contrast the automated and manual systems used to track, monitor, and report security baselines and policy compliance, describe the requirements to automate policy distribution, describe the configuration management and change control management, discuss the importance of collaboration and policy compliance across business areas, define and contrast security content automated protocol or SCAP, simple network management protocol or SNMP, and web-based enterprise management or WBEM. Also be able to describe digital signing, explain how penetration testing can help ensure compliance, and list best practices for IT security policy compliance and monitoring. So again, the key concepts are the baseline definition for information security system, tracking, monitoring, reporting for information technology, security baseline definition and policy compliance, automation of IT security policy compliance and policy configuration management and change control management, best practices for IT security policy compliance monitoring, and also the differences between public and private IT security appliance monitoring. Defining a security baseline. Taking your policies and building security baselines is a good way to ensure compliance. For example, suppose you have about 200 servers and an Active Directory server that ensures password rules. Configuring the servers to add AD to automate ensures that their passwords meet standard requirements. Additionally, if the password rules within the policy are compliant with NIST standards, then the Active Directory might be an effective tool to ensure that aspect of regulatory compliance. So baseline is a good starting point for ensuring compliance or enforcing compliance. Within IT, a baseline provides a standard focus on a specific technology used within an organization. When applied to security policies, the baseline represents the minimum security settings that must be applied. For example, imagine that an organization has determined every system needed to be hardened. The security policy defines specifically what to do to harden the systems. For example, the security policy can provide the following information. For the protocols, only specific protocols listed within the security policy are allowed. Other protocols must be removed. Or services. Only specific services listed within the security protocols are allowed, and every other service will be disabled. And accounts. An administrator account must be renamed. The actual name of the new administrator may be listed in the security policy, or this information could be treated as a company secret. The security policy would have much more information, but these few items give you an idea of what is included. Point is that the baselines can be complex, referencing multiple policies. A server baseline, for example, may be configured to enforce both passwords and monitoring standards. Baselines have many uses in IT. Anomaly based intrusion detection systems, or IDSs, are baselines to determine the changes in network behavior. Server monitoring tools also use baseline to detect changes in system performance. The chapter focuses on the use of baselines as part of enforcing compliance with security policies and detecting security events. For using imaging technology. Many organizations use imaging technology to provide baselines. Image can include the full operating systems, applications, and systems settings. This includes all of the desired security configurations settings required for a system. The figure on your screen shows an example of how imaging is accomplished. You start with a clean system referred to as a source computer. You install the operating system and any desired applications on the source computer. Next, you configure specific settings needed for users. Then you configure the security settings to comply with the security policy. For example, you could remove unneeded protocols, disable unused services, and rename the administrator account. You can lock the system down with as much security as you need or desire. Next, you capture an image of the system. You can think of this as being like taking a snapshot. Imaging captures the entire software content of the system at that moment. Semantic Ghost is a popular imaging program used to capture images of an operating system. Once you've captured the image, you can deploy it to other systems. The original image is often referred to as the gold master. Each system that receives the image will have the same operating system and applications. It will also have the same security and configuration settings. This baseline improves security for systems. It also reduces the total cost of ownership. Imagine that security policy requires changing 50 different security settings. Without the baseline, these settings would have to be configured separately across potentially hundreds or thousands of servers. Time involved to configure them separately may be substantial. Additionally, there's no guarantee that all of these settings would be configured exactly the same on each system when done manually. So roles and responsibilities. A baseline is a good place to start. It ensures that systems are in compliance with security requirements when they are deployed. However, it's still important to verify that the systems stay in compliance. An obvious question is how the systems may have been changed so that they aren't in compliance. Administrators or technicians may change a setting to resolve a problem. For example, an application may not work unless security is relaxed. These changes may weaken security so that the application works. Malicious software or malware, such as a virus, may also change a security setting. It doesn't matter how or why the settings are changed. The important point is that if it is an unauthorized change, you want to know about it. You can verify compliance using one or more of several different methods. These methods simply check the settings on the system to verify they haven't been changed. Several common methods include automated systems, random audits and department compliance, an overall organizational report card for policy compliance. So automated systems. Automated systems can regularly query systems to verify compliance. For example, the security policy may dictate that specific protocols be removed or specific services be disabled. For instance, the policy may require password protection screensavers. An automated system can query the system to determine if these settings are enabled and match the gold master. Many automated tools include the scheduling abilities. You can schedule the tool to run on a regular basis. Advanced tools can also configure systems that aren't in compliance. All you have to do is review the resulting report to verify systems are in compliance. For example, assume your company has 100 computers. You can schedule the tool to run every Saturday night. It would query each of the systems to determine their configuration and verify compliance. Then the scans are complete. The tool will provide a report showing all of the systems that are out of compliance, including specific issues. If your organization is very large, you would configure the scans to run on different computers every night. Random audits and departmental compliance. You also perform the random audits to determine compliance. This is often useful when IT tasks have been delegated to different elements in the organization. For example, a large organization could have a decentralized IT model. A central IT department manages some core services such as network access and email, and individual departments manage their own IT services. The organization still has an overall security policy. However, the individual departments are responsible for implementing them. In this case, the central IT department could randomly audit the departments to ensure compliance. Some larger organizations employ specialized security teams. These teams have a wide variety of responsibilities in the organization, such as incident response and boundary protection. They could also regularly scan systems in the network and randomly target specific department resources. It's important to realize the goal of these scans. It isn't to point fingers at individual departments for non-compliance. Instead, it's to help the organization raise its overall security posture. Of course, when the departments realize their systems have been scanned at any time, this provides increased motivation to ensure the systems are in compliance. And then overall organizational report card for policy compliance. Many organizations use a report card format to evaluate system compliance. These report cards can be generated from multiple sources, such as quality assurance program. Organizations can create their own grading criteria. However, just as in school, a grade of A is excellent while a grade of F is failing. The included criteria depend on the organization's requirements. For example, the following elements can be included in the calculation of the grade. Number one is patch compliance. This compares the number of patches that should be applied versus the number of patches that are applied. A time period should be considered. Patches that close major vulnerabilities might be considered critical and must be applied sooner. Security settings. The baseline sets multiple security settings. They should all stay in place. However, if an audit or scan shows that the settings are different, it represents a conflict. Each security setting is not in compliance is assigned a value. For example, every setting that is different from the baseline would represent a score of 5%. If scans detect 3 differences, the score would be 85%. And then number of unauthorized changes. Most organizations have formal change control processes. When these are not followed or do not exist, changes frequently cause problems. These problems may be minor problems affecting the single system or major problems affecting multiple systems or the entire network. Every unauthorized change will represent something less than 100%. For example, 15 unauthorized changes within a month will represent a score of 85%, or a B in this category. Once you identify the rules or standards, you could use a spreadsheet to calculate the grades. The administrator could pull the numbers from the scans and enter them into the spreadsheet monthly. You could use individual grade reports for each department that manages IT resources and combine them into a single grade report for the entire organization. Automating IT security policy compliance. The one thing that computers are good at is repetition. They can do the same task repeatedly and always get the same result. Conversely, people aren't so good at repetitious tasks. Ask an administrator to change the same setting on 100 different computers, and it's very possible that one or more of the computers will not be configured correctly. Additionally, automated tasks can take less labor and ultimately cost less money. For example, A task that takes 15 minutes to complete would take 25 labor hours. If an administrator took 2 hours to write and schedule a script, it results in a savings of 23 labor hours. Depending on how much your administrators are paid, the savings can be significant. Many security tasks can also be accomplished with dedicated tools. For example, the automated systems section earlier in the chapter lists several different tools with a short description of the capabilities. Now, if you plan to automate any task related to IT security policy compliance, you should address some basic concerns, including automated policy distribution and configuration and change management. So manual versus automatic monitoring and reporting. Early in this chapter, imaging was described as a method to start all computers with a known baseline. This is certainly an effective way to create baselines. However, after the deployment of the baseline, how do you ensure the systems stay up to date? For example, how could you deploy an image in the system on July 1st? July 15th, the organization approves the change. You can modify the image for new systems. How do you implement the change on the system that received the image on July 1st, as well as on the other existing systems? Additionally, if you didn't start with an image as a baseline, how do you apply these security settings to all systems on the network? The automated methods you use are dependent on the operating systems within your organization. If your organization uses Microsoft products, you have several technologies you can use. Some, such as SMS and SCCM, were mentioned previously. Another tool is group policy. So the benefits of automating security policy compliance include cost reduction. With full-time employees, it can be retasked. Efficiency due to computers monitoring policy compliance. Better reporting functions and data capture. Online real-time compliance reporting and monitoring. And also increased accuracy. So group policy in a Microsoft domain. Again, the group policy is available in Microsoft domains. It can increase security for certain users or departments in your organization. You can first apply a baseline to all the systems within an image. You can then use group policy to close any security gaps or increase security settings for some users or computers. This method can also ensure regulatory and standard compliance, such as with those controls required to protect credit cards under the Payment Card Industry Data Security Standards, or PCI DSS. If you look at the figure on your screen as an example, the organization named is ABC Corporation, and the domain name is abccorp.int. The secure password policy is linked to the domain level to ensure security passwords for all users in the domain. The organization could define a password policy requiring all users to have strong passwords of at least 6 characters. The organization later decides it wants to change this to a more secure 8-character policy. Administrator could change the security password policy once, and then it would apply to all users in the domain. Doesn't matter if there are 50 or 50,000 users. A single change applies to all equally. So the ITIL life cycle. The Information Technology Infrastructure Library, or ITIL, includes 5 books that represent the ITIL life cycle, as shown in the figure on the screen. The central part of ITIL is service transition. This relates to the transition of services into production. It includes configuration management and change management. ITIL isn't an all or nothing approach. Organizations often adopt portions of ITIL practices without adopting others. Configuration management and change management are two elements within the service transition stage that many organizations do adopt. So configure management, or CM, establishes and maintains configuration information on systems throughout their life cycle. This includes the initial configuration established in the baseline. It also includes recording changes. The initial public draft of NISTSP defines configuration management as a collection of activities. These activities focus on establishing the integrity of the systems by controlling the process that affect their configurations. It starts with the baseline configuration. Configuration management then controls the process of changing and monitoring configuration throughout the system's life cycle. Configuration of management database. A configuration management database, or CMDB, holds the configuration information for systems throughout the system's life cycle. Goals to identify the accurate configuration of any system at any moment. The configuration management database holds all the configuration settings, not just the security settings. However, this still applies to security. The security triad includes the configuration, integrity, and availability, meaning the configuration settings ensure the system operates correctly. A wrongly configured system may fail, resulting in loss of availability. Compliance technology solutions. Organizations use both emerging and existing technologies to ensure compliance. One particular challenge is how to update and track regulatory changes and new rules, including how to use them to coordinate policy management and compliance training. This section represents some of the notable technologies, such as COSO Internal Compliance Framework, Security Contents Automation Protocol, Simple Network Management Protocol, Web-Based Enterprise Management, and Digital Signatures. So the COSO Internal Controls Framework, integrated framework, was developed by the Committee for Sponsoring Organization of the Treadway Commission. This led to the term COSO. Organization was formed in 1992. The main idea of creating a framework of controls to ensure a company's financial reports are accurate and free from fraud. This COSO framework has evolved over the years, with the latest version published in May of 2013. Since 1992, both technology in general and the Internet in particular have evolved. Not surprisingly, technology information security has become major parts of the COSO controls framework. SCAP, the Security Content Automation Protocol, or SCAP, pronounced CCAP, is a technology used to ensure system and networks. It's actually a suite of 6 specifications. Together, these specifications standardize how security software produces identity and reporting security issues. CCAP is a trademark of NIST. NIST created CCAP as part of the responsibilities under the Federal Information Security Management Act. Goals to establish a standards, guidelines, and minimum requirements for tools used to scan systems. Although SCAP is designed for the creation of tools to be used by the U.S. government, private entities can use the same tools. The Simple Network Management Protocol, or SNMP, is used to manage query network devices. SNMP commonly manages routers, switches, and other intelligent devices on the network with IP addresses. SNMP is a part of the ICP-IP suite of protocols, so it's a bit of a stretch to call it an emerging technology. However, SNMP was improved over the years. First version of SNMP was version 1. It has significant vulnerability. Devices commonly use community strings for authentication. The default community string was public, and SNMP sent it over the network in clear text. Attackers used a sniffer such as Wireshark could capture the community string even if it had changed from the default. They could then use it to reconfigure devices. Web-based Enterprise Management, or WBEM, is a set of management and Internet standard technologies. They standardized a language used to exchange data among different platforms for management of systems and applications. Such as SCAP provides the standards used to create tools. WBEM also provides standards used in different management tools. Tools can be graphic user interface-based tools. Some tools are command line tools that don't use a GUI. Digital signing. Digital signature is simply a string of data associated with a file. Digital signing technologies provide added security for files. A file signed with a digital signature provides authentication and integrity assurance. It also provides non-repudiation. In other words, it provides assurance that specific sender sent the file. It also provides assurances that the file has not been modified. A public key infrastructure is needed to support digital signatures. A public key infrastructure includes a certificate authorities that issue certificates. Certificate includes a public key matched to a private key. Anything encrypted with a private key can be decrypted with the public key. Additionally, anything encrypted with the public key can be decrypted with the private key. Digital signatures provide added security for many different types of security compliance files. For example, consider patches and other update files. You would download these files and use them to patch vulnerabilities. If an attacker somehow modified the patch instead of plugging a vulnerability, you would be installing malware. Similarly, many definitions included for security tools are digitally signed. The digital signing. If a file is digitally signed, you know that it has not been modified. The following steps show one way that a digital signature is used for a company named Acme Security. The company first obtains a certificate from a certificate authority with the following steps. First, Acme Security creates a public and private key pair. Second, Acme Security includes public key that is part of its key pair to the security authorities with the company's request. Keeps the private key private and protected. Third, the security authority verifies Acme Security is a valid company and is who it says it is. The security authority then creates a digital certificate for Acme Security. The certificate includes the public key provided by Acme Security. Acme Security then creates the file. Then Acme Security hashes the file. The hash is a number normally represented in hexadecimal. Hex in this example is 123456. Acme Security encrypts the hash with its private key. The result is a string of letters. Remember, something encrypted with a private key can only be decrypted with the matching public key. Said another way, if you can decrypt data with a public key, you know that it was encrypted with the matching private key. Next step, Acme Security packages the file and digital signature together. and sends them to the receiving client. The digital certificate could be sent at the same time or separately. The next step, the receiving client uses a certificate to verify that Acme Security sent the file. Additionally, the client checks with the certificate authority to verify the certificate is valid and hasn't been revoked. The client decrypts the encrypted hash with a public key from the certificate. The received file is hashed given a code of 123456. This hash is compared with the decrypted hash. If they're both the same, the file is the same. In other words, it has not been modified. Additionally, it provides a verification that the digital signature was provided by Acme Security, because only the matching public key can decrypt data encrypted with the private key. Digital signatures aren't a new technology. However, their use with security tools and downloads has significantly increased over the years. A digital signature provides you with the additional tool to verify authentication and integrity for downloaded files. So, best practices. When implementing the plan for IT security policy compliance monitoring, you can use several different best practices. The following is a list of them. First is start with security policy. The security policy acts as a roadmap. It's a written document, not just some idea in someone's head. Without the written document, the actual security policy becomes a moving target, and monitoring for compliance is challenging, if not impossible. Create a baseline based on security policy. Use images whenever possible to deploy new operating system. These images will ensure the systems start in a secure state. And also accelerate deployments, save money, and increase availability. Track and update regulatory compliance rule changes. Firmly track regulatory rule changes as a routine. Map changes to these rules or to policies and configuration controls. Then update security policies and technologies as needed. Audit systems regularly. After the baseline is deployed, regularly check the systems. Ensure that the security settings that have been configured stay configured. Well-meaning administrators can change settings. Malware can also modify settings. However, auditing will catch these modifications. Automated checks as much as possible. Use tools and scripts to check systems. Some tools are free, other tools cost some money, but all are better than doing anything manually. They reduce the amount of time necessary and increase the accuracy. And then manage changes. Ensure that a change management process is used. This allows experts to review changes before they are implemented and reduce the possibilities that changes will cause problems. Also provides built-in documentation for changes. So public and private IT security policy compliance monitoring. So in the public domain, regulations require reporting on a timely basis. Compliance law requires specific reporting guidelines, and government laws stipulate when reports are due. In a private setting, reporting is set by owners with no set timeline. Government compliance laws may not apply, so reporting of the data may not be required, and problems often go undisclosed. So this chapter covers some of the technologies to ensure IT policy compliance. Imaging technologies can deploy identical baseline images for new systems. The chapter also discussed the importance of gold master image. However, the baseline is up to date only for a short period of time. As patches are released or other changes are approved, the baseline becomes out of date. Difference between the baseline and the required changes represents a vulnerability or a security gap. This gap must be closed to ensure systems stay secure. Many automated tools are available for IT administrators today. These tools can examine systems to ensure the baseline security settings are not changed. They can also scan systems for vulnerabilities, such as ensuring the computers have the current patches. Many tools include the ability to scan for issues and deploy changes to current systems. NIST publishes standards for these. These standards are resulting in the wealth of available tools to increase security for networks today. You read how penetration testing is an important test for an effective controls. You also read the case studies. Thank you.